Welcome back. In this lesson, I plan to give you an introduction to all the fundamentals in this course. So let's start with the very basics. Mechanism design is made up of two main branches, kinematics and kinetics. Simply said, kinematics is a study of motion path with no regard to forces. Kinetics is a study of forces that cause motion, control motion, or result from motion. And you can see how smart this is. Real-world dynamics involved in machinery and mechanisms are quite complicated, and we cannot really handle it as one bulk with everything involved. So we simply divide the study in two halves, achieving the required motion first, then worrying about the forces involved. Now these two things are not physically separable in the real world, of course, yet to simplify things, we study them independently. Let's wrap this point quickly with formal definitions before we move on. Kinematics is a study of motion without regard to forces. Kinetics is a study of forces on systems in motion. These two fields are the main components of mechanism design. In the normal design process, we start first with kinematics, designing the mechanism to perform its desired motion. But since F equals ma and the mass will remain constant, then the forces on the machine is a result of the acceleration of its parts, which is, in big part, due to the kinematic design of the machine. That's why kinematics is the foundation of mechanism and machine design. If you get it right, the rest will follow along well. So in this fundamental course, we will only focus on kinematics. I will cover kinetics in another course. We can generally divide kinematics into two branches, kinematic analysis and kinematic synthesis. In kinematic analysis, we determine the position, velocity, and acceleration of different parts in the mechanism. Kinematic synthesis, however, is concerned with designing the mechanisms to perform a certain function. The problems in these two branches, either design problem or analysis problems, could be solved either with algebraic equations or with graphical methods. Algebraic equations describe the motion of the mechanism in details, and these are usually solved using softwares like Mathematica or MATLAB. Graphical methods depend on the geometrical relations between different parts and can be solved using any CAD software. This course will focus on kinematic synthesis and especially on graphical methods to design mechanisms.